Hello. In this video, I will do example 4 of trigonometric substitution. So on example 4, we have to integrate the square root of 25 minus 4x squared times dx. So first we got to figure out what is our correct use substitution. So this 25 minus 4x squared is related to this rule. If you want, you can rewrite this as a power. So you can rewrite the problem as parentheses 25 minus 4x squared raised to the 1/2 times dx, right? Because x to the 1/2 is the same thing, square root of x. So if our rule applies to this, I believe our a value will be 5 and our b value is going to be 2. So what trigonometric substitution will we use? We'll use x equals a over b times sin of theta. Okay. So we said our a is 5 and our b is 2, so we're going to use the substitution 5 over 2 sin of theta. Okay. So the thing is, we got to find x squared because that's what they said. So let's find x squared. So x squared is basically squaring this whole thing, which is 25 over 4 of sin squared theta. Okay. So we could just start substituting in. It's going to be 25 minus 4, and then replace x squared with 25 over 4 sin squared theta, right? And remember, this is still all raised to the 1/2 times it by dx. Okay. Now, what do we do next? We will simplify. So it's going to be parentheses 25, and then negative 5 times 25 over 4, the 4's cancel, so you're just left with negative 25 sin squared theta. And this is all raised to the 1/2 times dx. So what we do next is, I see we could factor out a 25, so let's do that. If I take, so we can factor out 25 each term. So this would be 1 minus sin squared theta raised it to the 1/2 times dx. Now, is there any other substitution we can use? Yes, we can use one of our Pythagorean identities. So this 1 minus sine squared is related to one of our Pythagorean identity, sine squared theta plus cosine squared theta equals 1, right? So all you got to do is subtract sine squared theta from both sides, so you get cosine squared theta equals to 1 minus sine squared theta. Okay, so we're going to replace 1 minus sine squared theta with cosine squared theta. So let's do that. So 1 minus sine squared theta is cosine squared theta. Dx. So, oh, and then we're still raising it to the 1/2. So we're raising everything to the 1/2. So what's this 25 raised to the 1/2 and cosine squared theta raised to the 1/2? That would be simplified as 5 cosine theta dx, right? So all I did was I raised each term by 1/2. So 25 raised to the 1/2 is 5. Cosine squared theta raised to the 1/2 is just cosine theta. Okay, then what I could do is I guess I gotta we gotta put in terms of theta, so I have to somehow change this dx to a theta. So if we said that x equals 5/2 sine theta, right? What would be dx? Dx over d theta would be. So the derivative of 5/2 sine theta is 5/2, and then the derivative of sine theta is cosine theta, right? So what we're going to do is we want to get dx by itself, so I'm going to multiply both sides by d theta. Okay, so the d theta cancels, so you're left with dx equals to 5/2 cosine theta d theta. Okay, so what I'm going to do is replace that dx with 5/2 cosine theta d theta. So dx is going to be 5/2 cosine theta d theta. Okay, and then what we can do is we could take out this constant, this 5 and this 5/2 is really 25 halves. I'm going to take it out. And then you have cosine theta and cosine theta, which is cosine squared theta d theta. Okay, so how do I simplify, or what is the integration of cosine squared theta? Is there some kind of identity I can use? Yes. The identity you can use is trig identity. It's so cosine 2 theta equals to 2 cosine square theta minus 1, right? So what I could do, because I want to solve for cosine square theta, so what I will do is solve for cosine theta by first adding 1 to both sides. And then I'm going to get rid of this 2 by dividing both sides by 2. So on the right, you're left with cosine squared theta. And then on the left, it's what you're just left with, if I put the 1 first, so it would be 1 plus cosine of 2 theta all over 2. Okay. So I'm going to replace this cosine squared theta with this whole thing. Don't forget d theta. And then on the left, it's 25 over 2. So how do I take, well, what I would do next is, do you see this like 2 or this 1/2 on the bottom? I will take that out. So this 2 or this 1/2 is really 1/2, and just take it out because it is a constant. You have that 25 2 and then this 1/2. So now you're left with 1 plus cosine of 2 theta d theta. Okay. Now what we're going to do is take the integral of each term. So what's the integral of 1 in terms of theta? It would be theta. And what is the integral of cosine 2 theta? So yeah, if you want, you could, if you want to make your life easier, you could wait, so 25 halves times 1/2, that's 25 fourths. And then if you want, you can take the integral of each term. So the integral of 1 d theta plus the integral of cosine of 2 theta d theta, right? So what is the integral of 1 d theta? It's just theta. And then what is the integral of cosine 2 theta d theta? So you might have to do like a u substitution. So I'm going to use the u substitution of 2 theta. And then du would be 2 d theta. So what do I have to do to get, I have to get rid of this 2 because I don't have this extra 2. So to get rid of it, I'm going to multiply both sides by 1/2. So this is 1/2 du. And then over here, 2 times 1/2 is just d theta. Okay. So, so it's like saying the integral of cosine of u times it by d theta is 1/2 du. So it's like plus 1/2, because this is a constant, and then cosine of u du. So what is the integral of cosine? Sine, right? The integral of cosine is sine, and then our u is d theta, 2 theta. And then you still have this 1/2 plus this theta. And then remember, we took out a 25 fourths. So if you want, you could FOIL that out, and then don't forget the plus c. So it would be 25 fourths theta plus 25 fourths times 1/2, that's 25 eighths of sine of 2 theta plus c. Okay, then what we're going to do is the last step is draw our triangle, because our final answer has to be in terms of x. So let's go ahead and draw our right triangle. So in our right triangle, we said that we're given that x equals 5/2 sin theta. And then what we're going to do next is multiply both sides by the reciprocal of 5/2, which is 2/5. So this is 2x over 5. And then on the right, it's just the 5/2 and 2/5 cancels, you're left with sin theta. Okay, so if we do the SOHCAHTOA thing, sine theta, so sine is opposite over hypotenuse, so this 2x is the opposite, this 5 is the hypotenuse, right? So this would be 2x, and then the hypotenuse is 5. Do we even need to find this missing leg? Because if you look at our, we are, all right, where we stopped here, it's 25 over 4 times theta plus 25/8 times sine of 2 times theta plus c. So all we need to do is find theta, right? So I don't even think we need to, we didn't have to draw the triangle, because we have sine theta equals 2x over 5. All we have to do is solve for theta. So how do I get rid of this sin? By multiplying both sides by sin inverse, right? Okay, so on the right, sin times sin inverse, it disappears. So you're left with theta, which is what we want. And then on the left, it's sin inverse of 2x over 5. Okay, so our theta is sin inverse of 2x over 5. Yeah, we didn't have to draw the triangle. So our final answer is going to be 25 over 4 times theta, which we said was sin inverse of 2x over 5. So you can replace theta with sin inverse of 2x over 5 plus 25 over 8 sin of 2 times theta. So theta is sin inverse and then plus c. Okay, so that is your final answer. Okay, I guess I will stop here.